Okay, hi class. So now let's continue with 2.2 absolute values. Okay, are you familiar with the word absolute? Okay, usually we will play with the sign of modulus, that is absolute. So actually, what is absolute? Okay, absolute value of A, or we represent it as modulus A, is actually the distance of point A, alright, on the real number line, on our number line, okay, from origin. So here let's draw a number line. Here we have 0. Okay, you have A here. So what is the distance here? The distance is A. Okay, and if you have the negative A here, the distance is also, we can say as A, because distance is always positive. Okay, so on how we are going to represent this, actually we can write in form of a modulus, which is modulus A equal to A, and modulus negative A will also get A. Okay, thus, right, our definition of modulus A is actually, we have A if A greater equal to 0, and we have a negative A if A less than 0. Okay, you can see the symbol here. Here is less than 0, means negative only. Here is 0 and above. Okay, so one is positive, another one is negative. Or we also have another definition, okay, that we will use later. Our modulus A is also the same as sed A squared. Right, so this is our definition of modulus A. Right, so now we will continue with looking at our properties of absolute values. Alright. Okay, let's see properties number 1. Modulus A will always be greater or equal to 0. Alright, it is easy, right? Because we know that modulus A is equal to 8. Modulus negative 8 is also equal to 8. Modulus 0 is equal to 0. So our value will always be greater or equal to 0. Right. We go to the number 2. We have modulus A equal to negative modulus A. Alright, you can see the example before. Alright, either it is positive or negative inside, the final value will be the same. Okay, to the number 3, we have modulus A plus B is equal to modulus A plus B. Oops, now we change the position, equal to B plus A. Okay, now you just rearrange the number, you still get the same answer. Alright, next, number 4, we have a modulus A minus B is equal to B minus A. So here let's choose a number between two of them. Alright, this one, let's choose number 4 plus 7 is equal to modulus 11. So it is equal to 11. So we arrange it, we get rearrange it to plus 7 plus 4 is also equal to 11, modulus 11, so it is equal to 11. So it is the same. How about this one? 4 minus 7 is equal to negative 3. Modulus negative 3, we get 3 at the end. Modulus 7 minus 4 is equal to modulus 3. So at the end, we still get 3. So it has the same value. Okay, when we are talking about this one, I want you to stay alert. Plus, yes, modulus negative 3 equal to 3. Okay, and modulus 3, you get 3. Okay, let's say you have number 3, but you can't change it to be modulus negative 3. Alright, you get what I mean? Is it from modulus? It's okay, the value will be positive, but from a value, you can change it to modulus negative inside. Okay, because this happens. Alright, so next we look at properties number 5. Alright, what do we have? Because we have add, we have subtract, of course we will have multiply. Alright, our multiplication is modulus AB. You multiply both of it is equal, you multiply it 1 by 1. Okay, we multiply it. Do you want an example here? Let's give a simple number. 2 multiplied by 3 is equal to modulus 6. Alright, so it is equal to 6. So we change the direction. We change it as individual multiplication. So it will be modulus 2 multiplied with modulus 3 is equal as 2 multiplied 3, we get 6. So it is the same. Okay, next, because we have already have multiply, we have divide, okay, division. Alright, so we have our properties A. If modulus divide everything inside, is equal as the numerator, modulus of numerator divided by modulus of denominator, where the denominator is not equal to 0. Okay, so let's prove for this one. We have modulus 7 divided by negative 4. Alright, so it's equal to 7 over 4. But if you multiply it separately with its own modulus, so modulus 7 divided by modulus negative 4, so you will have 7 divided by 4. So it is the same value. We apply all properties that we know by solving this absolute equation. Absolute, the symbol, equation is here. Right. Okay. So, okay. So we continue with our 2.2 absolute values. Of how we're going to solve absolute equations of form. We will have 4 forms. You can see here, modulus equal to constant without modulus, modulus linear equal to linear without modulus. So you have modulus linear on the left and equal to modulus linear on the right, and you have a modulus quadratic equal to a constant number without modulus, right? So let's label it as form number 1, form number 2, form number 3, and form number 4. Let's look at form number 1. We have modulus AX plus B equal to C. Okay. Or it can be... Alright, so let's give you an example. Okay, for example, you have equation modulus x minus 7 equal to 2. Okay, so how we are going to solve this is write down on the left hand side as x minus 7 equal to 2, or okay, here you have to use the symbol or, okay, or union. Okay, next we will have x minus 7 equal to negative 2. So our solution is here is 9, however here it will be 5. Thus our answer will be in this form. In solution set, we write in solution set, so it is 5 and 9. Okay. Okay, so we look at so let's make it as the form here. We go to the form number 2. For form number 2, we have a modulus linear inside, and we have linear equation outside without the modulus. Alright guys, let's see, I give you an example. We have modulus x minus 2 equal to 10 minus 3x. Alright, so on the left we will have x minus 2 equal to 10 minus 3x union, or x minus 2 equal to negative 10 minus 3x. Okay, let's solve for this one. We will have 4x equal to 12, so x equal to 3. Next one we have what do we have? We have 3x here. 3x means that it can be 2x, negative 2, 8, so it's, sorry, x equal to 4. Alright, so here, when you have x inside modulus and x outside modulus, alright, outside modulus, you need to check your answer. Alright, so let's check our answer. For x equal to 3, we try to calculate left hand side is equal to 3 minus, we substitute in the original equation. Alright, so our original equation is here. So 3 minus 2 is modulus 1 is equal to 1. Our right hand side we have 10 minus 3 multiply 3, we get 1. So left hand side is equal to right hand side. So x equal to 3 is our answer. Okay, next we also need to check for x equal to 4. We start with the left hand side. Is modulus 4 minus 2 equal to modulus 2 equal to 2. Our right hand side is 10 minus 3 multiplied by 4. So 10 minus 12 is negative 2. So 2 and negative 2 here is not the same. Okay, thus I can write it as left hand side is not equal to right hand side. So x equal to 4 is not the solution. Thus our final answer is only x equal to 3. Okay. Yes, this is the highlight that I told you before. Because the value is negative, it will be maintained negative. You cannot, alright. Suddenly it is negative 2 because you want to make it 2, you want to put the modulus sign and make it 2. It is wrong. Okay, you cannot put the modulus as whenever you want. No, it cannot. Alright, it can only be used if we have the modulus sign here. Okay, and another highlight is if it is absolute equation. Alright, because we know that we want to separate them into two parts. One is positive and one is negative. Alright, we will use the symbol or here. Okay, union. Different with before. What did we have? Before this, we use intersect for our inequalities. Either it is linear or quadratic. Okay, we use symbol n because we separate it from one equation into two and use the symbol n. But here for absolute, you will use the symbol union or for. You cannot use n. Okay, please see the difference between them. Okay, so here this is our highlight. When you have modulus x and x outside the modulus, so you need to check the answer. So here we need to check. So here this is our highlight. When you have modulus x and x outside the modulus, so you need to check the answer. So here we need to check. Okay, I think I still want to use this page. Okay, because it's like we have a small things. So let's I draw the the stair here. Okay. Alright. So let's see the form 3. Our 3 here we have modulus ax plus b, modulus cx plus d. Okay, you have a modulus both sides. Okay, here I would like to recall back our properties. We know that modulus a is equal to sec a square. Okay, so we will use this on our form of absolute equation. Because you have modulus on both sides, you may change it into have ax plus b here, you have cx plus d there. Your modulus will change into sec square and sec square, and then you solve your equations. Alright, and the last one we have number 4. Form number 4, we have modulus ax square plus bx plus c equal to d. So it is just the same as before. We just separate it into two parts, equal to d, but with the symbol union or because it is absolute. Alright, negative d, and you just solve your answer. Our final answer, you can write it in the form of a solution set because we don't have interval. Okay, you can't use interval form because we don't have the interval here because it is absolute equation. Okay, when it is absolute equation, it plays with the value. Okay, so I think later I will put some example for form number 3. Okay, so we stop here for time being. Okay, alright guys, continue with still in 2.2. Alright, absolute values, how we can solve the absolute equations. So absolute means the symbol equation is this one. So usually the equation will come into 4 forms. Alright, we go to the number 1. Directly, you can just divide it into 2 equal to C or equal to negative C. Remember to use or, okay, for absolute equation. So the second one, number 2, positive on the left or negative on the right. Positive here, negative here. That's what I mean. Okay, next, I would like to explain the number 3. You have modulus everything on the left and on the right. Okay, here, I would like to go back to our definition. We have modulus A is equal to sed A squared. So here, we will use this to calculate, to solve this question. So we change everything by using this definition. So it is equal to ax plus b squared z equal to cx plus d squared z. Okay, that's how we are going to change. Alright, so for you to be clear about it, let I give you an example for this one. You have modulus 2x plus 1 equal to modulus x minus 3. So everything lies inside the modulus. So we change the definition by changing it to x plus 1 square equal to modulus x minus 3 square. So guys, what are you going to do is actually you square both sides. Why do we square both sides? Because we want to cancel the sed and square. Sed and square. So end up your equation will have bracket 2x plus 1 square equal to bracket x minus 3 square. Okay, because these two has been cancelled with each other. Alright, so what is your job? It's actually to expand for this one. Alright, so you will have 4x square plus 4x plus 1 x square minus 6x plus 9. So let's rearrange them to the left hand side, all of them. So you will end up getting 3x squared plus 10x minus 8 equal to 0. So can we factor? Okay, so you will get 3x minus 2, x plus 4. So x equal to 2 over 3, x equal to negative 4. So our final answer should be written in this form as negative 4 2 over 3. We start with the lowest to highest value. Alright, so that's how you solve the equation that have all modulus inside. Okay, so nothing left for you to do for this part. For form number 3, and we have form number 4. So you just rearrange them to positive or negative. Okay, as a highlight guys, if you can see, anything that you have to put as positive and negative, you need to use or in between the symbol or. And what another thing that I'm missing here, for form number 2, you need to check because we have x inside modulus and add outside modulus, like the example I showed before. So remember, you have to check, okay, because we don't know that whether you can accept both answer or not. So I think that's all for our solving absolute equations. Alright, so see you guys on the next video. Okay, let's continue with still in 2.2 absolute value, but for now we look at for part absolute inequalities. Alright, so absolutes, you know, it is involving modulus. Inequalities is our these four symbols. Alright, okay, let's first go to the properties. Alright, properties of absolute value inequalities. Alright, let's go for number 1. What do we have? We have modulus x less than a for a greater than 0. Alright, so modulus x less than a for a greater than 0, we can draw it on our number line. Alright, because we know for modulus less than a, that means we have a positive and negative a. So the distance, the solution lies between these two with empty circle. Alright, because our symbol is single here. Okay, this is for graph interpretation. How about we look at its algebra? Alright, for algebra, modulus a less than a is actually x is more than negative a less than a. Alright, or you can put it as x greater than negative a and x less than a. And the symbol n here, you can change it, use the intersection symbol. Alright, so this is for our number 1. Let's look at number 2. What do we have? Modulus x less or equal to a for a greater equal to 0. Alright, so here is the symbol double there. We're still playing with a and negative a, so our solution is involving dense circle. Alright, because the symbol is double. Alright, for algebra, let's go as x greater equal to negative a less or equal to a, or x greater equal to negative a and x less or equal to a, or we can change the symbol using the intersection symbol. Okay, so what is different actually between the number 1 and number 2? Here is the difference. Alright, when you have a single, so here will be empty circle, but here will be dense circle. Okay, the symbol maintained according to the equations. Can you see? Okay, it also continues here. Alright, so here is double. Alright, so next let's look at number 3. What do we have? We have a modulus, we have modulus x greater than a. Alright, so for a greater than 0. Let's draw. Because we are involving a, so we still have modulus x and a, so means we have a and negative a. Okay, for this one, maybe you can't see straight away, so let's do the algebra method first. We have modulus x greater than a, so that means you have x greater than a and x less than negative a. Am I right? You put it into, as one is positive, another one is negative. When another one is negative involving modulus, that means we have to put negative here. Alright, here you can't use and, you have to use or. Okay, so it will be, I will explain later on. We can arrange the value by putting the small one here, or means the symbol union x greater than a. So that means our number line will be from negative a to the left and from a to the right. Okay, let's go to the number 4. What do we have? Our last one properties is modulus x greater or equal to a for a greater equal to 0. Okay, so for this one, let's start with our algebra method first. Alright, for algebra, you have this one. Okay, let's put it in positive That's one side. Negative on the other side, negative A, so you need to change it, you need to reverse the sign, so it will be x less than or equal to A. Here will be R. Okay, so we can put the smallest on the left, less or equal to negative A, union x greater or equal to A. If you are confused, actually I just rearrange. Alright, it's just the same thing, I just rearrange. Okay, so here is you use R. So by this we can draw our number line, negative A and A. So less or equal to negative A means double to the left, greater, then circle to the right. Okay, so this is all about, if you can see, I will make two different between less and greater. Okay, if you can see here, for the less one, either it is single or double, if you define the value, okay, the number line that you get is between them, or we can say it as intersection. Okay, between them. That's why you need to use symbol and there. Alright, symbol and here and here. Okay, let's look at next one, which is our greater. For greater, okay, you can see here either single or double. If you draw the value, it will be the opposite one. One is to the left, another one is to the right. So here you need to use R as your symbol. Okay, so we can make conclusion here. It depends on our modulus x. Alright, either it is less or less equal, yeah, or it is greater equal. If it is less or less equal, you need to use intersection, and if it is greater equal, you need to use union symbol. Okay, for us to identify where's our conclusion or our solution lies. Okay, so this is what we get from our properties. All right.